Previously on Sound mini-series, we did a quick experiment to visualize a few types of sound waves on a virtual oscilloscope. And what did we learn? In the context of sound, amplitude is the volume, frequency is the pitch, and there are different types of sound waves that make the different types of sounds. In this episode, we'll be making a piano keyboard that shoots out bubbles, and we're going to be playing a little bit more with the P5 oscillator class. But before we get there, let's talk about how we're going to approach it. So we're going to be making a piano that plays musical notes, and to do that, we need to assign a specific frequency to each of the piano key. For example, a note A above the middle C has a frequency of 440 Hz. The frequencies that are audible to an average human is between 20 to 20,000 Hz. And actually, each animal has different hearing range. So if you look at this page here, a little bit of a sidetrack, you can see that these are the range of the hearing ranges of different kinds of animals. And we are, based on this graph, we are between 31 Hz and 19,000 Hz. And we're quite similar to a cow. A cow has a little bit of a wider range, and also a chinchilla and a horse. A chinchilla is a type of rodents. Each animal also communicate with different frequency ranges too. For example, whales, seals, and fish actually communicate at a lower frequency range, so some of the sound that they make we can actually not hear. The frequency that we're actually going to be using is between 32 and 512, which are the rhythm frequencies, or the frequencies at which are commonly used to make music. And if you look down here, you can see that there are different types of frequencies here, and also a corresponding MIDI note. The lower the frequencies, the lower the notes. So the lowest C here has a frequency of 32.7. Let's play it. We can almost not hear it, right? It's quite low. Let's try middle C at 261. And then C in the middle of treble clef, a little bit higher, 1 octave higher. So it has a higher pitch. And as you can see here, the frequency values are a little bit difficult to use with the decimal points and all. So what we're going to do is that we're going to be using a MIDI note, which are these numbers that are corresponding to a specific note and also a specific frequency. And we're going to be using a method called MIDI to Freq within the P5 sound library to convert from a MIDI note value to a specific frequency. Lastly, before we start, as mentioned at the beginning, there are different types of sound waves that create different types of sounds. We're going to be playing around with 4 basic types of sound waves: sine, square, triangle, and sawtooth, which are the basic types of sound waves used to make music or to synthesize music. And we're going to be using a method within the P5 oscillator class called set type to change around between each one of these sound waves. Alright, so to create a piano, I'm going to start by declaring a few variables. The first one is octave. And 1 octave has 12 keys on the piano. So 7 white keys and 5 black keys. I'm actually going to be creating the white and the black keys separately. So I'm going to define 1 octave as 7. And then I'm going to declare an octave as 1. And then num will be octave times 7. Why don't we first draw a loop that goes from I equals to 0 to I less than num, I plus plus, and I'm going to create a rectangle at location x, y, and with the width and the height of each of the keys. So to do that, I'm actually going to declare 3 more variables. So the first one is going to be white x0, so the x position of the white keys, and then the second one is going to be the width, and then the last one is going to be the height. And I'm going to set y as a common variable between the white keys and the black keys. So I'm going to put it at 300. All right, and then here inside setup, the white x0 will be at 0. I want it to be starting from the left side of the canvas. And then for white width, it's going to be based on the size of the canvas, the width of the canvas divided by the number of keys that I want. And then for the height, I'm going to set it at 100. All right, so now inside here, what I need to put in is x and y, right? So white x0, y, and then white width and white height. And with the first one, it has to be white x0 plus I times the width of the white keys, right? To get it spaced out evenly. All right, and then now how about we actually set the size of the canvas to be a bit bigger at 600. And if I change the octave to, let's say 2 or 3, now we get the number of keys that we want. All right, so let's do the black keys. So we're gonna define 3 more variables too, and let's call them black x0, black width, and black height. And inside setup here, let's start with, I'm actually going to put x0 down here. Let's start with the width. So black width, I want the width of the black keys to be actually half of the size of the white keys. So white width divided by 2, and then the black height will actually be also half of the white keys. And then as for the starting x value for the black keys, so the black keys are going to be where? It's going to be here, right? In between 2 of the white keys. So because the rectangle mode that we use has the x and y coordinate at the top left corner of the rectangle, what we need is that we need to find the middle point here and then subtract by half of the width of the black keys, right? So we're going to do white width minus black width divided by 2. And we also want to shift it out by white of x0. And then now we're going to copy and paste this line of code and change from white x0 to black x0 times I plus, it's still going to be spaced out evenly by this increment of the width of the white keys, and then the width of the rectangles will be black width and black height. All right, and let's try it. Oops. Oh, this has to be white height. All right, and as you can see here, we only see half of the black keys, and that is because we're drawing the white one and the black one, and then this second white rectangle is on top of my black keys, right? So what we actually want to do is we want to actually draw 2 loops, starting with the white keys and then ending with the black keys. All right, and then how about we color it as well? The first one is white and then the second one is black. And as you can see here, this is not the piano that you used to see because there are too many black keys. So we want this one, the first and the second one, we don't want this one, right? So it's C, D, E, and then F is this one. There's no black keys in between. And then we need this black key, this one, and we don't need this one. So if you look at this, the one that we don't need is the third one and the seventh one. So what we can do is, what if we write a conditional statement that says if I is not or equals to, so it starts at 0, right? So 0, 1, and 2, if it does not equals to 2, and I is not equals to, so 2, 3, 4, 5, and 6, right? 6, then draw these black keys, and otherwise don't draw it, right? All right, so we got it to apply to the first set of octaves, but it doesn't apply to the rest. And to fix this, we can use an expression called modulo. And modulo is an expression that will return us a value for every second and every sixth of the keys. And to do that, we just use a parenthesis sign, and we want to divide it by 7 because that is 1 octave, right? So 7 for both of these. So what this does is that it basically divides I by 7 and returns the remainder between these two divisions. So if let's say that it is the 9th key, right? The 9th key, 9 divided by 7 has a remainder of 2. So that key is not going to be drawn. Same as this, right? So it is going to be the 13th, right? 13 goes into 7 one time. It has a remainder of 6. And so that key is not going to be drawn. So which one is that? 0, 1, 2, 3, 4, 5, 6, 7, 8. This one is not going to be drawn. 9, 10, 11, 12, and then 13, right? And so this should apply to all of the octaves. All right, and then now we can change the number of octaves. I want to set it at 4. Perfect. All right, so next what we're going to do is we're going to put this inside a class. So let's come to this arrow here, click the plus sign and click create file. I'm going to call this file key.js for the piano key. Let's go to index.html and then come to this line of code. We want to integrate this new file into the program, and we can do that by copy and paste this line of code, change the name to the name of the file that we just created, in my case key.js, and that's it. Let's go back to key.js. So I'm going to call this class key, and then inside the constructor function what we need is x location, y location, the width, right, for each of the keys, and the height for each of the keys. Also, I want to put in the color. So let's put these as the parameter x, y, w, and h, and c. Then we want another method called display, and we're basically going to be drawing a rectangle at these locations. So the variables that we provided for the black keys and the white keys will actually just be the global variables. I'm going to keep them as those. All right, let's go back to sketch.js. So how about I label this as piano keys? And then what I'm going to do here is I'm going to create an array, actually 2 arrays. One called white keys, and then the other one, let's call them black keys. All right, and then inside here, we're going to use a for loop to create a bunch of key objects, right? So the first one, let's start with the white keys. It's going to be new key at what location? So it's going to be these locations here, right? So actually we can just copy and paste this inside here, and we need to add the last part, which is color. For the white key it will be white, and then for the black keys it's going to be new key, and then we're going to put these set of codes, right? And then we also want to put color as black. And then now that we created these key objects inside here, all we need to do is call white keys of i.display, right? And same thing here, it will be black keys of i.display. We don't need these colors anymore. Oh, black. Let's go back to key.js. Oh, I forgot to put in fill this.c. All right, okay, so what I'm going to do next is that I'm going to make it interactive. So each of the key that I press, I want it to turn a different color. So I'm going to start by writing a conditional statement that say if mouse is pressed, and mouse is pressed is a built-in Boolean variable that turns true when I press the mouse. So if mouse is pressed, and so let's start with the black keys. And black, actually it needs to be inside a for loop because we want to check all of the keys, right? So I++, so we're gonna put this inside here. So if mouse is pressed and black keys of I is greater or equals to, no, actually if mouse X, if the mouse X location is greater or equals to the black keys, dot X, and mouse X is less than or equals to black keys of I dot X plus black keys of I dot width, right? So if it's in between here and here, so that's on the X side. So we want to do the same thing but for the Y side. So actually let's move this out. So This is the X part. And then for the Y part, so if mouse Y is greater or equals to black keys of I dot Y and less than or equals to black keys of I dot Y plus black keys of I dot Y, no, dot H, mouse Y. All right, then we're gonna change the color of the black keys to, how about, let's make it red. All right, let's try it. All right, so we need an else statements too. So if this is not true, if the key is not pressed, then the color will be black. All right. Okay, let's do the same thing for the white key. So we can just copy and paste this. And then just change this to white keys. And we're going to change the color to white when not pressed. All right. But there's an issue here. So let me press the black keys. Now the white key is also activated. And that is because the conditional statement is true for both. So what we can do is that we want to make sure that if the black key is activated, then the white key should not. And what we can do to fix this is we're going to create a variable called active keys, which I'm going to set initially at 0. Then every time the black key is activated, we're going to increment it by 1. And let's print active keys here. So it is 0. I click the black keys, then it becomes 1, right? So what we can do now is inside this conditional statement, we're going to add one additional thing that says and active keys is equals to 0. That means that the black key is not pressed, right? And this way they work. All right. Next, what we're going to do is we're going to add some sound using the P5 oscillator class. And we went through the basic in the previous episode already. First, I'm going to create a variable called note, and I'm going to set it as a parameter note here. And then we're going to create another variable called OSC, and it's going to be a new oscillator object, P5 oscillator class. And then we need to also start it. And the last two things that we want to create, first is the amplitude, which I'm going to set at 0 initially, and we're going to set the frequency to the frequency of a specific note here, and these are going to be the MIDI note value that I mentioned before, right? And we're going to use a method called MIDI to freq, which converts from a MIDI note to a specific frequency that we want to play. All right, and then let's write two additional method called play sound, which plays the sound. So what we want to do is we want to change the amplitude to 1, and I'm going to put this ramp up value to get to this volume of 0.1 second so that we don't get the clicking sound. And then I'm going to create another method called stop sound, which basically just turn off the volume, right? I'm also actually going to, how about, set the color, this .c here, to be the color red instead of putting it out in sketch.js. And then here, I'm going to set it back to its original color. So let's call this variable this.oc for our original color and change this to this.oc. Now that we have changed this part, let's go back here. So every time that we press the key, instead of changing the color here, what we want to do is we want to actually call play note, right? And this one we'll call, no, not play note, play sound. And then this one is stop sound. Same thing here will be play sound and stop sound. And then inside the object creation here, we need to add the note. So I'm going to just put in 60 as the MIDI note. So all of the keys will have the same sound for now, and then we can just change it afterwards. And it seems like I'm missing Am I missing a... parentheses? I think it should be okay now. Let's try it. Oh, this has to be OC. So let's set this dot C equals to, let's just do this dot OC. Alright. Alright, so all of the keys can be played, and it all plays at the same exact note of MIDI note of 60, which is a C. Alright, so it's working. So what we want to do next is actually, I'm going to create MIDI notes, and I'm going to create one variable and 2 arrays. So the first one is the starting MIDI note, which I'm going to set at 48. So I want the very first one here to be at 48, and then I'm going to create white C, an array called white increment, which are these values here, and then black increment to be these values here. So as you can see here, each of the lines here has 7 values, and these are going to be added to the number 48 to get the corresponding MIDI note value for each of the piano keys. So there is a more efficient way of doing this, but this is how I'm going to approach it for now. And in here, instead of 60, we're going to put in starting MIDI plus we're going to add white increment of I, and I'm going to use a modulus expression here and divide it by num. So in case that you put in an octave that is greater than 4 and we don't actually have enough of these values here, it will just loop it back to value index of 0 and so on, right? And we're going to do the same thing for the black keys as well. Then we're going to change from white to black. Then let's play it. Perfect. So next we're going to add a drop-down list, and this will allow us to change the sound waves from the current sine wave to a different types of waves. To do that, we can use a method called createSelect, which creates a drop-down menu. And what we want to do is first create a variable, and then we're going to copy this. So first I'm going to create a new function called GUI for graphical user interface, and let's paste all of this. Then we're going to create a variable called, let's call it wave types. How about that? Wave types. And we're going to change these mine select. So this method create the drop down list, right? And then this sets the position, and I want it to be actually below the canvas here. So we're going to do height, and for the X position, actually the X position will just be 0. And then for the Y position, let's do height, and then let's add maybe a margin of 10. And then I also want to change the size to be 100 pixels. Next, we're going to give it 4 options as well. And the options that we're going to give is going to be sine, square, triangle, and lastly, sawtooth. And then this one will be set the selected option to, so this one is going to be what it initially is set to. So let's set it to sine. All right, so I can delete these comments out. And then make sure you call this function inside setup. All right, so we have 4 different options in this drop-down list, but it's not tied to anything yet. So what we want to do is we want to, inside draw, create another variable, and then that will be set to the selected option. Up here, I'm going to create a variable. Let's call this type. And inside draw here, we're going to set type to be equals to wave types dot selected, right? And then this type, I'm going to set it as an argument. an argument inside the play sound method for both of these, right? And then we have to go back to key.js and then add type here. And where would we add this type argument? We're going to be using the method called setType, right? And setType basically set the type of the sound wave. So here, let's click run. And I change to triangle. Still sounds like a sound wave sound. And that is because if we go back to sketch.js, you can see that I used this letter as an uppercase letter, and that actually doesn't work. So what we need is that we need to actually put in, inside the setType method, we need to put in the lowercase values string. So what we can do is we can use a JavaScript method called toLowercase, and to do this, I'll just print it just to show you. So now it becomes a lowercase value, right? And now change to triangle, to sawtooth, square. Sounds quite similar. All right, so it's really loud. So how about we add a slider to actually control the volume? So what we need to do is to use a method called createSlider, and similar to createSelect, we need to do this. So first, we're going to create a variable. Let's call it volume. And then inside here, it's about to rain outside, so if you hear the sound, I apologize. Right, so I'm going to create a slider called volume. And it's going to be in between the range of 0 and 1, because that's the range of the amplitude, right? And the third argument that I'm going to put is actually where I want the slider to start. I want it to start at half of the amplitude at 0.5. I want to set the position also to be at the very bottom. So 0, height, and I'm going to add 30 as the margin, so it's a little bit lower. And the size will be the same as the drop-down list. And then let's click run. So now we have a slider. But as you can see here, I can only move from 0 to 1. And it's not even at 0.5. And that is because the increment goes between 0 and 1 at 1 increment. So what we can do is we can provide a fourth argument, 0.1. And that will give us a smaller increment of 0.1. And then inside here, first I'm going to create another variable called v, and then inside here v will be equals to volume dot value. So let's print v. You can see that it starts at 0.5 and then it just can change back and forth, right? All right, so this will be our volume. So I'm going to actually add v as an extra argument in here and also in the white keys. All right, so let's go back to key.js. Now we have to add an extra variable here, right? Let's call it v, and v will be the volume, this amplitude that we set inside this argument here. Let's try it. So I think you can hear it better if it's a different kind of sound wave. Oh. Alright. Still, it was quite loud before, but you can hear that it actually works because at 0, you can't hear anything. Alright. So comes the last part. Let's shoot out some bubbles, and we're going to do it using a particle class. So first, we're going to come to this arrow here and create another JavaScript file. Let's call it particle.js. And then don't forget to integrate it into our program, right? Same thing here inside the index.html file. All right, so inside the particle class, we're going to start with x and y location, right? So this.x equals to x, this.y equals to y. And then let's create a method called display. We're gonna, let's just draw an ellipse at this.x, this.y, and let's give it a size of, how about 10? And then we're gonna go to key.js. So I'm going to comment this as position and color. This one is sound. And then the last one is going to be particles. And we're going to create a particles array. And basically we're gonna create new particle objects when we play the sound. So we're gonna use a method inside an array class called push, and we're gonna be pushing new particle object at this.x and this.y. And with this, we need to write another method. Let's call it update particles. And what we want to do is we're going to loop through the length of the particles array. And what we're going to do is we're going to display. We're going to call the display method, right? Particles of i.display. We need to call this update particles method too inside sketch.js, and we're going to call it here. So it's going to be white keys dot update particles. Same thing for the black keys. All right. Something's not right here. Particles is not defined, so this has to be this.particles. All right. Do you see that? We have a bunch of circle along the keys. But first, what we want to do is, right now it's at the top left corner of each of the key. I want to move it a little bit out. So I'm actually going to add a third argument inside the particle class. I want to know the width of the keys. So let's do this.w equals to width. And then inside the key.js file, right, we're going to add in this.width. And then if we go back to particle.js, we're going to be drawing these ellipses at this.x plus this.width divided by 2. All right, so now it's in the middle. But we want it to move, create two more variables, this.x. So the movement in the x direction, I want it to be random between -1 and 1. And then the movement in the y direction, I want the bubbles to move up. So I want it to be a random value. How about between -2 and -5? And then we're going to write a method called update. And update basically is going to be updating the position of x and y by dx and dy. All right. And then inside the update particle here, we also need to call the update function, right? All right, let's try it. Whoa. Something's not right.
A few moments later.
Right, so what I did wrong was I remember when I was trying to add more parentheses inside the sketch here, I accidentally put the parentheses around this 2 for loops here. So it actually is part of this additional for loop. And so that's why we get that weird looking particle moving around. So what we need to do is, so I was debugging it. Let's comment this out. Let's try again. All right, so looks pretty good. You can change this. Okay, so with particle systems, what we need to do is that we need to get rid of the particles that are off the screen, right, that are done. So inside the particle class, let's also write a method called finished, and we're going to check if this dot y, the y location, is off the screen to the top. So I'm going to do less than negative, how about 30? So just to make sure that it's really off the screen. So we're gonna create a variable called done, set it to true, and then else this dot done will be false. And let's create this dot done to be equals to false initially. Inside update, we need to call the finished method, right? And we call a method inside a class by just putting this dot and then the name of the method. Now, we're going to be calling this, checking whether the particle is off the screen or not. And then once that's done, inside the update particles here, we want to delete the particles that are done, right? So if you look at my particle systems videos, you would know that we need to loop it backwards, and you'll see why. So if I do, if this dot particles of I dot done is equals to true, then I want to remove it, and I can use a method called splice. And basically splice remove an object of that array that I just put in, which is I, which is when that particle is done. And then the second argument is 1, because I only want to remove one object at this index. So if I do this, let's try it. Do you see that flickering effect here? And the reason that happens is because by looping it forward, because of how the array and the splice function works, it skips some of the objects. So we want to loop it backwards. So we're going to start with this dot particles dot length minus 1. And if I is greater or equals to 0, then we want to subtract it. And then if we do this, then you don't see the flickering anymore. Alright, so just to show you that it really removes the particle, so why don't we print the length of this array. So it will go down to 0 eventually. Alright, and one more thing that I want to change about the particle class is the size. I actually want to set the size to be random between, how about 5 and 12. And then we're gonna change this 10 to this dot size, this dot s. Alright, the last part is let's make it pretty by adding more colors. What I'm going to do is I'm going to change the color mode from the default RGB to the mode called HSB. So first, let's come to the setup function here, change the color mode to HSB. HSB stands for hue, saturation, and brightness, where hue is the color wheel from red to red, and it ranges from the value of 0 to 360. And then saturation is the intensity of the color, and brightness is how bright or how dim the color is. And I'm going to change the color of the particles to like a rainbow-ish color. So let's create a variable called H. I'm going to start it at 100. So I told you that the range of the color wheel is between 0 and 360, but I want it to be just the range of bluish to pink. So I'm going to start it at 100. And then inside update, I'm going to say that if this dot H is less than 300, then I want this dot H to be incrementing up by 1, and else I'm going to reset it back to, actually, let's do 150. And then inside display here, we're going to fill the color with this dot H. Saturation will be at 100 and 100, so at its full intensity. And then I actually want to set the stroke to the color white. So let's try it. Okay. All right, so now we need to change colors on the key parts. So the stroke for this, I want it to be black. And then the fill will be the same, so. All right, and then I want to change the color when the key is pressed, this color here. Okay, and then let's change the background to be more like an ocean blue color to this. All right, let's do, how about square? Let's reduce the amplitude. Let's try it. A little bit more. here. There's a lot more that I'm going to explore within the sound library, so stay tuned for the next episode.